IP addresses have a 32-bit format, and those 32 bits are separated by a decimal in groups of fours, octets, pairs of fours. So this is an octet, this is an octet, this is an octet, this is an octet. If you look back at the previous lesson about binary formatting, we got to this 172 by turning on the 128 bit plus the 32 bit plus the 8 bit plus the 4 bit. That gives us 172, right? This is the IP address itself. Accompanying this IP address is a subnet mask. What the heck is a subnet mask? A subnet mask is what helps you to identify what part of the IP address belongs to the network versus the specific host on the network. Remember in the previous conversation, we talked about how there are many computers on the network, but every computer in the network has a specific IP address, i.e., there are many people that lives in the house, but every person in the house has a specific social security number, right? So if we look at the subnet mask helps to say, okay, this is the address to the house. However, in this house, this letter is going to Jared, or this letter is going to Don. It goes to a specific person. So the subnet mask identifies what the network address is versus the IP address. Let me break that down for you. The subnet mask value consists of, you guessed it, 4 different octets, 8 bits per octet. So if we look at this and we go 1, 2, 3, I'm sorry, and we go 1, 2, 3, 4, 5, 6, 7, 8 space 1, 2, 3, 4, 5, 6, 7, 8 space 1, 2, 3, 4, 5, 6, 7, 8 space, right? This will be your subnet mask and how it looks. In order to identify what's the host versus the network, you turn bits on and off. The difference with the subnet mask is when you start to the far left, and you can only turn on a bit if its preceding bit is turned on. What the heck do I mean by that? So let's say we turn this first bit on starting from the far left. That represents 128, right? To turn, we can't just skip this third bit and the second bit and go to the third bit and turn it on and say our subnet mask has a value of 128 plus 32. It doesn't work that way. In order to turn that 32 on, you have to turn on this 64-bit. So that means your subnet mask value in this place would be 128 plus 64 plus 32, which is 224. Now, this is key because this automatically means your values can only be certain numbers. And your subnet mask value in each octet can only be 255. You know what? Let me start from scratch. It can only be 128, 128 plus 64, 192, 192 plus 32, 224, 224 plus 16, 240, 240 plus 8, 248, 248 plus 4, 252, 252 plus 2, 254, 254 plus 1 is 255. These are the only values that any subnet mask octet can be by default, because you can't turn on a bit unless its preceding bit is turned on as well. All right. So for each octet in the IP address, you line up the corresponding octet in the subnet mask. So in this case, let's say that this value was, let's say that it was 255, dotted decimal, 255, dot 255, dot 0, right? What does this mean? What does this mean? This means that all the bits, that means that all these bits that are 255 are turned on. Just follow me, follow me. How do we know they're turned on? Because in order to get to this 255 number, you have to add all of these up, which means every bit is on. And in the subnet mask where every bit is turned on, that means that that corresponding part of the IP address belongs to the network. It's the house address. So if all of these bits are turned on, that means 172 is part of the network. So write that down. Oh, my bad. That means 172 is part of the network. Let's go to the next octet. The subnet mask that corresponds to this 253 is 255. So that 253 is part of the network. Let's go to the next octet. The subnet mask that corresponds to this 189 is 255. So all the bits are turned on. That means that 189 is part of the network. Well, now we get to this 184. In the 184, the subnet mask octet that corresponds to it is 0. In order for it to be 0, that means that no bits are turned on. So what does that tell us? That tells us that every number found in this section, in this last octet, is going to be a specific host, a specific individual in the house. So that means that this 184 is a specific computer in the network of 172.253.189. Got it? Let's do it again. Do it again. Here's another example. Let's say we had 172.254, 187, 189. Same subnet mask. What does that mean? This 255 octet corresponds to this 172. All the bits are turned on, so 172 is part of the network. This 255 corresponds to this 254. All the bits are turned on, so that means this 254 is part of the network. All the bits in this 255 that correspond to this 187 are turned on, so what does that mean? It's part of the network. This 189 is 0, so what does that mean? It means any number after this 187 is a specific host on the network. So your network ID is 172.254.187.0. 255, because you always have to list the subnet mask. They go hand in hand. 255, 255, 255, 0. Watch it over and over and over again. And I promise you, like magic, it's just going to jump out to you. All subnetting is calculation of subnet mask versus IP address. The IP address can be any number from 0 to 1, from 0 to 255, because you can just mix and match and turn on bits in the binary scale to define your number. However, the subnet mask cannot be, because the only way that you can turn on a bit in the subnet mask is if its preceding bit has already been turned on. Meaning, if you're at the 128 and you want to turn on the 64, that's fine. But you can't go from 128 and turn on the 32 without turning on the 64, which means you've got to add all three of these, right? And in order to get to this 255, you got to turn on every bit, which means that particular value in the IP address is part of the network. All right, I know I said a lot, but we'll go over it. Just go over it time and time again. It'll make sense. You have different classes of IP address, different groupings, right? Truly, in today's society, in today's IT world, it doesn't really matter too much, but I'll go over it just so you know it. A class A address is any number from 1 to 127. And a class A subnet mask is 255.000. Automatically, if you look at this, this should tell you that the first octet, all the bits are turned on. Yeah, automatically it should tell you that all the bits are turned on, right? So that means any number in this first octet is going to be part of the network. So whether it's 1, 2, 3, 94, 98, 126. That's part of the network ID, right? Because this is the default mask for Class A. Class B range is any number starting at 128, going all the way up to 191. A Class B subnet mask is 255.255.0.0. So what does that tell you? The first two octets in a Class B are always going to be part of the network ID. Class C address, 255.255.255.0, right? So what does that tell you? The first three octets are always going to be part of the network address for a Class C. And then there's this Class D of 224 all the way to 239, which is typically used for multicast. It's a different video, different conversation.